Hello, beautiful people, and future me. Welcome to another programming workout, which is my try to be better programmer. We'll start with a 5-minute typing practice. And then we'll continue in some programming exercise. And this week, apparently, we are taking execute program exercises. So let's do that. Oh my god, I did not run the clock. Okay. Okay, but we are in for 5 minutes now, so I will start clock and we will count up to 25. I see it in the OBS studio. So and I have 3% error, which is good. 41 is not bad for me. So good. And now we go to execute program, and I believe I have 3 courses available to me. So we will pick randomly one using this wheel of names. SQL. I have a review. Okay, so what we are doing, first of all we are creating a table, ID name people, and then table cats, owner ID name, and then we are inserting a mayor and his cat into cats. Then we are selecting person name, a mayor. So there's a mayor. We will select, I'll get people array, person name. Then we will select the cat from there and we will push the cat name over there. So find cat names should give us Mrs. Fluff. And it's array. It is array. Okay. Okay, next thing. Create a table, users, ID name, comments, user ID, comment. Okay, so important stuff. Name is not null. Users ID is not null. That is the foreign key. And text is not null. Okay, so now we are inserting 2 comments can reference the same user. So we are doing what? Inserting stuff. So this will return nothing. This will just return empty array. Well, I mean our exec function. So this will do this. Yeah. Okay, what is this? Users can reference no discount at all. Yeah, so with this comment, this is like really helpful to me. Now without reading all of this stuff, I can tell that it will be this without reading it. I think that is detrimental to my exercise. Well, I will read it anyway. So we are creating a table users to three fields: ID, which is the primary key, name, the null, discount, and discount is foreign key in discounts. It can be null, but it has to be unique. So then we have a creation of the table discounts with 2 columns, ID and discount code. And in the next exec, we are just inserting user without the discount ID. Okay, that is okay. Next thing we do have here is what? I will pour water into my tea. So create table users. ID, name, discount ID. That sounds familiar. That sounds exactly that looks exactly the same as in previous example, including the discounts table. So now two users can't reference the same discount. Okay, now I can write just error, and I don't even need to read. Remove those commands for exercise. Amir uses discount and shares it with Betty. Yeah, so we are trying to insert into users a discount ID, and discount ID is the same, but if we have a look here, it says unique. So there cannot be in that column in the table two of the same value. So this is error. Next one. Create table people. Okay, ID, which is primary key, name, not null, cats, there's owner ID, but it's not foreign key. It's not reference. And we have so Emir owns Mrs. Fluff. So we insert Emir 100 and then Mrs. Fluff into the second table. And we have the other thing, which is Kino and his cat, and 101. Betty, Kino, well, Betty and her cat, yeah. And now we will select name. So we will get, I got this name from cats, where owner ID is 100, that is Mrs. Fluff. Okay, what next? Uh, Table users, ID integer primary key, name text not null. Then we have a comment, user ID, that is the port key. ID not null. Comment must reference a user. Yeah, so values, uh, comments, user ID is not null, and we are trying to put in null. So here we go. And have a second chance. And I forgot this will be an array, and that was how we are finding Amir. Amir has Mrs. Fluff. I like so. Okay. Quiz. Discounts and users and comments. Let's write some code. You can solve this problem using only what you learn, blah blah blah. Each test, we will be passing testing here. Tests, edit code, to pass all. Create user, discount and comments tables. User can have one discount, but have no discount at all. We've given you the basic table structure, however the constraints are missing foreign keys, nullability and uniqueness. Insert the appropriate constraints using test as a guide. So users can't reference discount that don't exist. Okay, so we don't have the foreign key set up. So users references, and it will be discounts, and it is ID. like so. So this is failing, but now it shouldn't run. Did it run? Okay, so we fixed this one. This one seems to be okay. Users can have no discount. Uh, it's okay, so we don't have to insert null, but in here, but integer null. If I do this, that works. Not work. I can do it explicitly. I'll leave it there. Then what else? Two users can't reference the same discount. Okay, so that means it will be unique constraint on ID on a discount, like so. So this is the third test, and that should be okay now. Ah, discounts. This I did it in discounts ID here. Where do I put it? Here. That will be it. That will be it. Run. Yeah, you forgot that. Now, comments can't reference users that don't exist. Okay, so that is the foreign key. They even say it in here. So in the comments table, a user ID is a foreign key, and the foreign key is in a users table, and it is the ID. So that is the 1, 2, 3, fourth test. Run. It's good. Comments can have no user reference. Okay. So our reference will be not no. And after that we will pass everything, I think. Run. Yep. Okay, what are the last two? Comments can reference user. That's good. And the comments can reference users which themselves refers discounts. Okay. That was nice and easy. And we will choose between those two. The run tests. What is okay? Math, seal. Yep, this one I want. Two it is. Right, it's almost always the second one. The last one, I mean. Okay. Simple joins. Foreign key. Let us guarantee that rows in one table correctly reference rows in another table. With that guarantee in place, we can ask the database system to combine the table's data for us. In this lesson, our goal is to produce a list of every cat's name along with their owner's name. We could write that code in JavaScript using a nested loop that executes one cat query per person, but that would be inefficient. SQL can do it in one query. Here's our cats and owners database, and we'll use this database throughout this lesson, but it will always begin empty in each code example. Okay, so this is our database right now, but it will be empty. They inserting in something. So we have a people with ID, that is the primary key, not now, and first name, that's all the data there is. So then we have a cat, ID is the primary key, not now, in here. And we have a owner ID that this is different syntax. Because normally I would expect like for owner ID, integer not null, and then references people ID. So this is like explicitly said something. Maybe that first one is like the SQLite thingy. I don't know. But we have the constraint in here, foreign key, owner ID, and the references people. So we have a two columns, two fields like the data, not really counting the primary key. And then this is really interesting. Foreign key, how is it? Foreign key. Then in bananas, we put the name of the field, and then it's the same way as it was, like references and reference like the table, and in bananas you put the field in the table you're pointing to. All right. Amir has a cat named Fluff, so we are inserting Amir and Fluff, and Betty has a Kinu. Okay. We can build our cats and owner list by joining the two tables together into one. First, we'll do the simplest possible join. People join cats, giving us combinations of every person with every cat. It will look strange, so we don't recommend dwelling on it. We'll improve it soon. Okay. Select from people join cats. Okay, so selecting everything from people and join cats. So this is the normal select part, and the new thing is join, and then we say the table and what we will get. So we have a first name, ID, name, and owner ID. First name. Okay, so let's see how it goes. So we have a ID first name, ID owner ID name. So what is here missing is the foreign key from the cats table. That's just that does not get in there. And this is first name. So we have a ID first name, and then we have a ID and name in there. First name Amir ID. It's reversed. It's just no, it's not. I'm confused about the order in which they are put in here. Okay, so that's Amir. And we have a lot of things in there. So we have a Amir in here. Then we have a Amir in there. Then we have a Betty. Okay, that's kind of like all the permutation we can have. So Amir here is in Mrs. Fluff. Then we have a Amir and Kinu. Then we have a Betty and Mrs. Fluff and Betty and Kinu. This is interesting. We have a one ID, but we have a ID here and here. So here's ID1, here's ID1, and here's ID2. Okay, 1, ID2. So that is ID of the cat. Definitely. So it select the value, the first name, and it kind of combines it with everything in here, which is ID on right. with the record in here, and that is 1, 2, 3 fields. So Amir and everything else come from the cats. Then Amir and also everything comes from the cats. And then we have a Betty and everything else comes from the cats, and Betty and everything else comes from the cats. Interesting. The join gave us every combination of a person and cat, whether or not they are related via order owner ID. There are 2 people and 2 cats, so the join gave us 4 rows, 2 times 2. Emerald Miss Fluff, Emerald Kinu, Betty and Kinu, yeah. If we had 100 people and 100 cats, then this will give 10,000 rows. Each of the 100 people would be independently combined with each of the 100 cats. You can think of it like this. For each person in the people table, for each cat in the cats table, return a row with the columns for that person and this cat. hmm The join has all of the columns for from people, ID and first. I did not saw the ID of the people. There's no ID in there. It starts with first name, and the ID is only the thing we get from the cats. So it doesn't. The ID is missing. And all the column from cats, name, other ID, both tables. Both tables have an ID column, which is awkward because we can't have 2 columns with the same name. The cat's IDs are binning here, so we see them rather the people's IDs. We'll address the issue of conflicting column names in more detail later. Okay. Maybe because they are later on in there. Might be the case. To make our join be more useful, we can add a on clause. On is like where, but it applies specifically to joins. We select where, but we join on. So we join on field or column. For our cats and owners lists, we want all pairs of people and cats where people ID equals cat's owner ID. Okay. So so we are joining on two thing, and we are kind of like on a value. We are joining on a value. Like this should be equal to that. Like this should be true. So we are joining cats on, and we have to reference the table name dot the field name, and here the same thing, the table name dot field name. It's weird that it doesn't do it for you. Can we get on foreign key maybe? Who knows? So now I suppose we've got 2 results, well, 2 entries in our result, and that is true. And now we have a mirror, still 1 ID, not more, but now Mrs. Fluff belongs to Amir, and Kinu is Betty's cat. So that is what would we expect. This is much better. Our condition was people.id equals cat's owner's ID. So people and cats get matched up. For example, the cat with owner ID 100 gets joined with person 100. Amir gets matched with Mrs. Fluff because our cat's table has a foreign key that associates cat's owner ID to people ID. We'll know our cats will always be matched with their correct owner. There's a simple rule for thinking about what join will do. It's always correct to think about basic joins as two nested loops with a filter like this. Okay, because normally I would be just thinking about it like a pairing process. Like I have a mirror, find the record, the row based on this condition, return it, and for each of the column you well, let me see the filter thing. For each person, for each cat, if the on condition is true for this person and this cat, return a row with the columns. Okay, we can think about it like that. Maybe the SQL implementation is something like such, like that. So we no 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 no, and we started 31 minutes ago. Okay, write a join that joins people and cats on cat's owner ID equals people ID. It was reversed in here. Make sure that you join people to cats in that order. Okay, we'll try. Select from uh, people join cats on. Is it like so? Yeah. Then we will say cat's owner ID, cat's owner ID equals people ID. PO people. Okay, so there is one thing to learn, and that is like the order of this thing is not important. People can be first, or the cats can be first. Doesn't matter. We'll get the same thing, I believe. And it says, okay, so first is Amir, owner ID 2, owner ID that. We have a Mrs. Fluff, and then we have a Betty. So we've got exactly the same result as we did before. With our cats and owners matched, we can pick the columns that we want with S, like we've done for the basic selects. For example, uh, select name as person from blah blah blah. In a join, data is identified by the table it comes from, like people.firstname as person. Okay, so here we will have to specify that. Write a join that joins people and cats on cats owner ID equals people ID using S. Return it in form of person cat. Okay, well, we'll do that. So we will select. I want to see this. Select. So uh, people dot first name as person. Then we want get dot name as what was it? Cat. Uh, what was the syntax? Now I do from. I think so. From, and it will be people join the other table, which is cats, on, and here goes our condition. You know what? I will make it more beautiful. Join cats on, and here will be our condition. We want cats dot owner ID equals people dot ID. Here we go, and it's correct. I love it. I'm usually kind of afraid. Well, from time to time I do typo, and it hinders my progress. But it's okay. I'm training. Usually, the order of tables in a join doesn't matter. Cat join people is the same as people join cats. There are two cases where join order may matter though. There are two cases where join order may matter though, depending on your database system. The first case is query optimization. In rare cases, your database engine may optimize a complex join badly, causing it to be slower than it could be. Reordering the join may help. Okay, that's interesting. And the second case is when there are duplicate column names. Oh my god. When we join the tables, blah 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 blah. Okay, I completely lost where we ended. I was coughing. Oh, sorry. So the first word. Hold on. Close the door in here. Alright, I'm back. No, fine. Second case, okay. First case is query operating. Okay, so we reordering join my help. Okay. The second case is when there are duplicate column names. When the joined tables have duplicate column names. The last table in the join wins. Okay, there's an example from earlier the lesson. So on a conflict of the name, we'll get the last uh, last. We will get the column from the last table, which has that column. Uh, Lesson. We select people join cats with no s to alias to the column names. Yeah, and the ID is the cat's ID. Notice that the ID columns returned are the cat's IDs 1 and 2. If we reverse the order and select cats join people, the ID column will be people's ID 100 and 200. It's common for tables to have the same column names, especially for ID columns. This can get very confusing, so it's best to use s to explicitly alias every joined column, rather than blindly selecting star. That will make your SQL code more clear to other programmers. We recommend writing those aliases on their own lines, indented inside the select. So there's okay, so each individual columns, cats as that, people as that. Okay. Yeah, it's nice. It's readable. I like it. I will implement it. I will incorporate it, include it into my coding practice. And we shall continue. So, well, let's just see. This is cat ID, this is person ID. Yeah, okay, good. We've been treating join as if it returns a table. The proper term is relation, which means it has rows and columns that and supports operations like where, as, join, etc. So that is relation, not a table. Okay. If a join combines two relations into a new relation, does that mean that we can join on the result of a join? Yes, we'll see that in a later lesson. Okay, good. So we can join relations. Relations are the core concept in SQL databases. We've called them SQL databases so far, but relational databases is more correct term. SQL is just the most popular relational query language. There are many kinds of relations. A table is a relation stored on the disk. A join gives us a relation that the database constructs on the fly based on our join condition. Even select one gives us a relation. It has one row with one column named 1. That's why executing that statement gives us an array of objects as if we were selecting from a table. We could join a table against select one if we wanted to. Yeah, because that is the relation. Okay, so we will have a select one and we can do join, whatever. Okay. When querying relations, we can use all of the query operation that we already seen of the table, as, where, etc. In the example above, we already did that with as. Did we? I don't see it very well. I'll trust you. When we use where with joins, it filters the rows just like it does with a normal table. The where can see columns from both of the joined tables. Okay, that's important. So we have a select people first name as a person, cat's name as a cat. So these are those two columns from people. Oh, this you do it like this, like keyword line, keyword line, keyword line, keyword line, keyword line. Okay, I got the pattern. Um, Well, there's a keyword as well. It kind of, I think I get the gist. I think I get the gist of it. So, select from join on where. It's readable. I like it. I like it. I like this style. I will do it. But the thing is, the point here is the where, and the where sees like the columns from both of the joined tables. So we are still referencing here the people first name. I wonder if I can use person equals Amir in here. Can we? I don't know. Exec. So people first. So this is the same, but now we will select the Betty and her cat. So it will say person, and here we'll say Betty, and wait a moment. Here it says select people, person, and then cat. How come here is cat first and then the person? Huh? Cat, this will be uh, Kino. I must be the most annoying user. Maybe I am, maybe I'm not. The worst what can happen will be that they will stop answering. They will stop answering. Okay, so what if we join people and cats, but some people have no cats? They won't show up in the results because on people ID it's never true for a person with no cats. Okay. So, for example, Betty's ID is 200. If no cat's owner is 200, then no cat can be paired with Betty on our join. Betty won't show up in the results. Amir and Mrs. Fluff will show up because they are still related. So, delete from cats from owner to 100. Okay, so, and we will have here the result, and it will be person that is Amir. And then we have a cat, and that is Mrs. Fluff, like so. When a person has multiple cats, the join will find all of them. One important note, though, suppose that Betty owns two cats, Kinu and Kim, the query will not combine the cats names into an array like, yeah, that will be two rows, right? Instead, the join returns two separate rows. Yep, that and that. So here we have one insert into cats, and that is Kim, 200 Kim. Then we have a select, and we have a person and a cat. So it will person, and person is Betty. Then we have a cat, and that is Kinu. But we will get a second result, and that will contain Betty as well. Betty and cat is Kim, like so. So just read what we assumed. So yeah, we are selecting from people join the cats on people ID equals cats owner ID, and the condition is where people first name is equals to Betty. That looks good to me. Use a join to find cats and their toys. The join should return two columns aliased with as_cat, the cat's name, and toy, the toy's name. Cats and their toys. Okay, so we have here the definition of the tables. So we have a cat's ID and name, and then we have a toys, foreign key, cat ID, foreign key. Is this foreign key or is this foreign key? I think this is foreign key. Yeah, because it even said, like in the previous example, a foreign key. Remember, foreign key. This and then there was references cats ID. Not now. Okay, now we are inserting some value in there. There's a cat, Mrs. Fluff, Kinu, and then we are inserting toys, Kinus, and no, this is not Kinus. This is, yeah, this is Mrs. Fluff's Kinus and Kinus. Shy guy. Berta Moser, shy guy. Moser. I like that name. Mouser. Alright, so we'll select, what do we want? Cat as the cat name, so we will select cats dot name as cat. Then we want select the toy's name, so it will be toys dot name as toy, from cats, join toys on. Did they did like on the, yeah, they did on the next line on, and here we will say cats ID equals to, was there a dot? There was a dot, right? Cats ID. I wonder if I can like do this as well. This kind of reference the Is it the same or not? Uh, E equals toys dot cat ID, and we are expecting those three results. So we are selecting cat and toy from cat, join toys on this. Oh, it looks good. You'll sometimes see the simple joins from this lesson called inner joins, which is the full technical term for them. We can even write cats inner join toys if we like. However, that does exactly the same thing. It's not necessary. So I have just learned inner join. Okay, inner join is the most simplest then, I think. The existence of inner joins implies that there are also outer joins, and it's true. They are much less common, so we won't look at them in detail. We will see one type of outer join in a later lesson though. Okay? And we are finished. Almost an hour. Okay. So that, ladies and gentlemen, we are way over the time, so we are definitely done. And done is always better than perfect. So, have a nice day. Bye.